Unlocking the mysteries of gamma ray thunderstorms, NASA Fermi Gamma Ray Space Telescope. In the realm of nature's grand spectacles, thunderstorms stand as both captivating displays of power and puzzling phenomena beneath the cumulus clouds and electrifying lightning lies a remarkable and little known occurrence. Terry Terrestrial Gamma Ray Flashes or TGFS. NASA's Fermi Gamma Ray Space Telescope has emerged as a vital tool in unraveling the enigma of TGFS, revealing their prevalence, origins, and significance in Earth's atmospheric processes. Dawns of thunder and gamma rays. TGFS are a form of high energy radiation that occurs within the confines of thunderstorms under specific conditions. NASA's Fermi telescope has played a pivotal role in this realm, providing crucial data that showcases the frequency of TGFS an astonishing 1100 times a day. This exceptional revelation is the result of meticulous observations conducted by the Fermi team, shedding light on an aspect of thunderstorm previously shrouded in mystery. Combining forces Fermi radar and lightning data in a groundbreaking leap forward, new research marries Fermi's detections with ground-based radar and lightning location data. The synergy of information has unveiled that TGFS emerged from a wider variety of storm types than previously postulated. Within thunderstorms, interactions among rain and snow particles lead to development of positive and negative electrical charges across different sections of clouds. When the electric field surpasses the cloud's insulating capabilities, it triggers a lightning flash. Most commonly, lightning occurs within the confines of the cloud and intra-cloud flash, the gamma ray emission mechanism. However, TGFS introduced a remarkable twist during the upward phase of an intra-cloud flash. Accelerated electrons surge towards the upper regions of the storm. These electrified particles, moving at speeds nearly equal to that of light, emit gamma rays as they interact with air molecules. This phenomenon has been illuminated through the use of global lightning location networks, allowing scientists to determine the position of TGFS with unprecedented accuracy, broadening the horizon. Radar insights. Remarkably, the integration of Fermi's data with next generation weather radar system has revealed that TGFS occur within a diverse array of storm types. Even storms with the weakest updrafts have been found to produce TGFS. Furthermore, these studies have pinpointed the consistent altitude range of TGFS occurrence, typically between 7 and 9 miles above the Earth's surface. This altitude consistency has inspired the belief that TGFS may also form at lower altitudes, broadening the potential scope of their occurrence beyond the visible spectrum. Fermi's limitations. However, Fermi's capabilities are not without bounds. TGFS occurring at greater depths within the atmosphere emit gamma rays that are significantly weaker. As a result, Fermi might be undercounting such events. This revelation suggests that TGFS could be even more prevalent than current data indicates, prompting a revolution of their frequency and significance in Earth's atmospheric dynamics. A new frontier for scientific explorations. Armed with this newfound knowledge, scientists are poised to embark on a fresh wave of inquiry. They aim to trace the correlation between TGFS and storm intensity, evolution, and structures. The tantalizing prospect of understanding the role of DGFS or as natural particle accelerators in Earth's atmosphere beacons, promising insights into the underlying forces that shape our planet's most powerful atmospheric phenomena. A grand finale, thunder and promise. In the grand finale of this captivating narrative, the thunderous applause of nature's energy is underscored by peeping telemetry and the promise of scientific discovery. The collaboration between NASA's Fermi Gamma Ray Space Telescope, ground-based radar systems, and lightning data has ushered in a new era of comprehension, bringing to light the electrifying secrets of gamma ray thunderstorms that have long eluded our understanding. That's all.